the previous section, we wrote a function that read a file into a list of dictionaries. Just to refresh your memory on that, essentially what we had is we had this function read portfolio, and what you could do is give it a file name, and then you would end up with a list of dictionaries as a result. That list had 7 entries in it, and then each entry was a dictionary that looked like that. What I want to talk about here is how to do more advanced calculations on that data. And to start that off, let's talk about the most important thing of all, which is the for loop. Turns out if you have a bunch of data, one of the things that you're frequently going to have to do is iterate over the data in order to do calculations. So the for loop is the first thing that you're going to use a lot. It turns out if you do a for loop, you'll go one item at a time over that data. So what we're seeing here is it's printing out a list of dictionaries, and I'm just seeing the contents of the data. Now, what I'm going to do next is talk about some different ways of working through that data in different kinds of calculations. I'm going to do that in the window down below, partly so that I can leave the data up on the window where you can look at it and then kind of piece it together with what I'm doing. The very first thing that I'm going to do is actually a repeat of that total calculation that I did. Let's say I wanted to calculate like the total cost. I might do something like a for loop where I would say for holding in portfolio, total is equal to holding shares times holding price. This is something that we did before, but essentially what we're doing is iterating over the data and doing a mathematical calculation. Here's another kind of calculation that you might do. Let's say I just wanted to collect all the stock names into a list. Maybe what I would do is I would make an empty list, and I would say for holding in portfolio, names append, holding name. What I'm doing here is more of a data collection kind of thing. I've made a list, I'm iterating over the data, and then I'm building up a new list that has the contents of that. I could even take that kind of a step further. Let's say I wanted to find out all of the holdings where there were more than 100 shares. Maybe I make a list more 100, and I say for holding in portfolio, if holding number of shares is greater than 100, more 100, append holding. What's going on here is this is kind of like a filter that's taking place. And I'm just collecting information about, like certain entries in the data. So I find 2 entries, CAT, 150 shares, Microsoft, 200 shares. Turns out that these kind of calculations, extremely common on data to do these sorts of things. And you'll see that they all have a kind of a common pattern, if you will. They all do a for loop, and then they do something with the data, whether it's filter the data, sum up the data, collect data, and so forth. Because this is so common, I actually wanted to talk about one of the absolute most useful features of Python, something known as a list comprehension. Turns out it's a shortcut that can be used to simplify a lot of these problems. For example, that total calculation that I did, I could rewrite that as a single line. I could say I want to make a sum where I say holding shares times holding price for holding in portfolio. I do it as a one-liner. You can look at that and say, wow, what just happened there? What is going on here is that statement in the square brackets is actually constructing a list kind of behind the scenes and then feeding it into the sum function. This is this list comprehension feature. If I do holding shares times holding price for holding portfolio, what you're going to see is it makes a list for me. It's like making a temporary list, and then that's what's going into the sum function. I can use that same thing to collect data. Like I could say names is equal to holding name for holding in portfolio. And that would do the same thing. What it's actually doing is going through the data and collecting that and returning it back. I could even do that more 100 thing using the same technique. I could say, well, why don't you give me all the holdings for holding in portfolio if the number of shares is greater than 100? What I've done there is essentially a query on the data. It's like, go over the portfolio, give me everything that matches that criteria. You can change it up. Like if I only wanted the stock names, I could say, why don't you give me the names of the stock where there's more than 100 shares? Then it would come back and say cat Microsoft. If you've done anything with databases, by the way, this actually reads very similar to something like a query on a database. Select name from portfolio where shares is greater than 100. It's very much that idea. what I wanted to do is actually run with this idea a little bit and actually perform a useful calculation on this data. Essentially what this data file has is it has information about a bunch of stocks that I purchased. Essentially, I purchased 100 shares of AA on June 11th, 2007 at that price. And then, it has other entries in there. What I want to do is actually find out whether this portfolio of stocks is up or down in value based on like today's stock market. So in order to do this, I'm going to start with some of the things that I just did. One of the things that I'm going to start with is this calculation of collecting all the stock names. So I'm going to start by getting the names. The reason I'm doing that is I just want to know what is in my portfolio. Like what stocks do I own? So this comes back and it tells me I own these stocks. Immediately I can look at that and I can see some kind of warts in there. One of the warts is that I have duplicate stock names. Turns out that I bought Microsoft and IBM on 2 different dates. So I have like 2 entries for that. One of the ways to get rid of duplicates, take a list and turn it into a set. So if I wanted to have unique names, I could make a set out of names. Keep in mind, one of the features of sets is that you drop duplicates. It turns out that if that is what I know that I want, I can actually do it in one step. What I'm doing here is using something known as a set comprehension. What you do is you use this list comprehension syntax, but you replace it with a curly brace. If you do that, Python knows you're building a set. It will give you unique items. It can be a very convenient way of like deduplicating data. All right, so what I've got now is I have a bunch of unique stock names. The problem that I'm going to look at next is how would I go about finding like the current price of those stock names? My goal is to find out if I'm a good stock investor or not. And what I would like to do is query the stock market and say, hey, what are the prices of that? To do that, I'm going to do a couple of things. One of the things that I'm going to do is I'm going to make a name string by taking all of those names and joining them together. This might look a little bit funny, but this is how you make a string where you take a bunch of parts and you like concatenate them with a common separator. So what I've said is the separator is a comma, and I want to join all those strings together. Okay, so I'm going to get a name string there. Now, why am I doing that? The reason I'm doing that is I'm going to go back to the trusty URL request module for a moment, and I'm going to make a request out onto the web to get a bunch of stock quote data. Turns out that you can get this information from sites like Yahoo. So what I'm going to do is go to the Yahoo site and essentially ask it for stock quotes on these names that I'm providing. That looks really cryptic. I had to look that up on the web, by the way, what that was. But essentially what I'm doing is making a request saying, hey, I want to get some stock quotes, and then I want to read the data back. Now what's going to happen here is you're going to get some data that has some numbers in there. Okay, so 72, 51, 9, 27, and so forth. These are essentially the prices of the stocks that correspond to those names of the stocks. I have the names, and then I have the prices. To get that data in a more usable form, I'll say price data is equal to data split, and look at the result. What I've done is I've taken this string, I've split it up into prices, and now what my goal is I'm going to try to pair that up with the stock names that I had. And now I have some price data. How do I get those two things to kind of go together? To do that, I'm going to introduce another Python feature, which is the zip function. Turns out the zip function is a really interesting way of taking like 2 different sequences of data and then doing a pairing. I'm going to zip the unique names with price data. In a little for loop like that, I'm just going to print it out to start. Okay, so you do a for loop. What you're going to see is a pairing. It essentially says, okay, cat is 72, AA is 927, and so forth. That sort of pairing like that is something that I could use to build a dictionary, actually. It turns out if you use the dictionary function and you zip like 2 different things together, like a bunch of names and some data, what you'll get is you get a dictionary where you can look up the different values. I can come in here and ask, what's the price of cat or what's the price of IBM? It's kind of cool. It's like, I've gone out on the web, I've fetched the data, I've actually managed to pair up the data in an interesting way. It's still not perfect. One of the things that's a little bit annoying is that the data is actually not properly converted. Like if you look at these prices, it's actually showing as a byte string. I don't know how to do calculations with that, or at least not in a meaningful way. Like if I were to take the price of cat and multiply it by 50, I would end up with like 50 copies of a byte string. So that is not quite what I want. But it turns out that there's a way to clean the data up. I'm going to say prices is equal to curly brace, name, float price, for name, price, and zip, unique names, price data. This is almost the same as that dictionary building thing that I had before. Turns out that this feature is something known as a dictionary comprehension. What I'm doing here is I'm telling Python, make a dictionary. The key is going to be name. The value is going to be float price. And then I do a for loop that kind of indicates where those things come from. All right, so now I have a dictionary that has stock prices in it. What I can do is look up a price given the name of a stock. Now, what I want to do is tie that back to my original goal of finding out whether I'm a good stock investor or not. What I can do is I can say, let's figure out the current value of this portfolio. I'll set it to 0. I'll do a for holding in portfolio. And then what I'm going to do is update that by taking the number of shares that I have and multiplying it by the current price. This is the neat trick. What I'm doing is I'm using the name of the stock as a lookup key in this prices dictionary. I know that that's going to work because I collected all the stock names from the portfolio. Those names that I got were the ones that I had in my portfolio. I'm going to get the name, I'm going to look up the price, and this will tell me that the current value is $50,000. Turns out that last calculation, I could also reduce that to something that's basically one line long. We could say sum holding shares times prices holding name for holding in portfolio. Okay, so back to like a one-line calculation. If I want to find out like the change in value of my portfolio, then I could do something like that. Okay, so I'm up about $6,300. I don't know whether that makes me an expert stock investor or not, but at least it's not a negative. There's a lot of kind of like moving pieces of what I did here, but here's the essential aspects to it. First of all, the for loop, that's how you iterate over data. So you see that being used a lot. There are some variations on the for loop that I used. For instance, that zip function let me iterate over 2 different data sets at the same time. Useful to know about that. And then these operations like, set comprehension, list comprehensions, and so forth. There are very useful ways of like collecting data, performing calculations on data, like the thing I've highlighted. We got the unique stock names. Down here, we're building dictionaries, with one-line statements. This could be, an extremely useful thing to know about. In fact, in a lot of my day-to-day Python programming, this is the kind of thing that I'm doing a lot. Reading data out of a file, reading data out of a database, transforming that data, filtering the data. These are kind of the essential tools that are used to do that.